COMSOL Multiphysics Lecture 2, Deflection of a Cantilever Beam. Open a part file in SolidWorks. And now XY plane, enter sketch mode and draw a rectangle or a square. And we place the dimension as 50 by 50 and extrude it into a meter. So this is a meter long beam. I'll save the file on desktop. And preparing step 1, add in the software, which is already done. The second step for preparing CAE analysis is to load the toolbar, and this is the toolbar. This is preparing step 2. And preparing step 3, we don't have to arrange the icons. So we have finished with the preparing steps, which is adding the software or loading the software and loading the toolbar and arrange the toolbar. Now we're going to proceed with the 6 steps for implementing CAE analysis. And the first one is drawing the 3D model and open a study. In opening the study, COMSOL will be docked inside SolidWorks software environment. And just as I said in the lecture 1, this is a function available only after version 5.2. Before 5.1, you can only live link both softwares. And now you are inside COMSOL environment. First of all, you have to choose solid mechanics as the physics. And in solid mechanics, you have to choose from statics, dynamics, and model analysis or frequency analysis. I'll choose stationary or statics. Done. So I've defined the type of analysis and also draw a 3D model. So I have finished with the first step for CAE analysis. I've draw a 3D model and open a study. And for the second step, I'll define the material. I'll add a material, or I can add a material in the material library, or I can add a blank material. In last lecture, I added material in the library, so now I will define a blank material. And for Young's modulus, I'll enter the value 3 times 10 to the 11 Newton per meter square or Pascal. For the Poisson ratio, I'll give it 0.3. And density is not necessary right here, but it is required, it seems. So I go ahead and define the density for steel, which is 7850 kilogram per meter cube. But generally, density is not necessary in a static analysis. In dynamic analysis, density is required. But now I might as well enter the numerical value for density, because it might be required in the software, but it is not necessary for the implementation of calculation. So I have defined the Young's modulus 3 times 10 to the 11th and the Poisson ratio of 0.3. So I finished with defining material. This is the second step for CAE analysis. And the third step is to generate mesh, and I'll choose a final mesh and build. And this is the mesh that I've got. For the fourth step, I need to apply boundary conditions and loading. So I'll choose fixed constraint and choose this area as the constraint. And there's no confirming step or confirming function in COMSOL. For example, in ANSYS, you need to apply the process, but in COMSOL, there's no such process. But you have to be very careful that make sure that this item is here, so that the constraint is effective. Now, apply boundary load on this area, the force application area, and the type of force to be concentrated force, and the direction of the force in y direction, and the magnitude of the force minus 100 or 100 Newton in negative direction. So I have choose 4 things in COMSOL force definition. The first one is to define a concentrated force or pressure, force divided by area. The second is to define the area on which the force will be applied. And the third is choosing the direction of the force, and then finally the magnitude of the force. So now I have finished with defining the 4 steps on CAE analysis, and these are called preprocessors for the analysis. Up to this point, the whole problem was fully defined, so I'll go ahead and run the study or compute. And this is the 5th step, or step 5 of CAE analysis, and step 6 is the result, and the default result is the stress. If I want to define a plot for displacement, for example, I will have to right-click the mouse on the result and choose 3D plot group. And on 3D plot group, I have to right-click the mouse, choose surface. And on surface, I need to right-click the mouse and define deformation and choose the function here on surface. It is the default that displacement will be shown. If you do not want to show displacement, you have to change here for the content of this surface. So now I have finished with 3 definitions and then get this result. So it is quite a tedious process, but it is how COMSOL goes. So the result definition is quite tedious, but you can also show other things such as animation. You can define animation for these plots. You can also show the numerical value of the displacement, such as right-click the mouse and choose point evaluation and choose certain points and evaluate. You get the 0.21247, which is very close to the theoretical value of 0.213. If we get a mesh finer, we'll get 0.213. So we can see that the result is correct. There's also some other functions, such as derived values as an average value on surface. For example, I choose this surface and evaluate. The number that I get here is the average displacement on this area. So we can also proceed with defining the average value of certain area or certain line. So this is the second lecture for COMSOL.